So this is a remainder problem, and we were told that in this first formation A, if we have 5 members in each row, then the last row has 3 members. So essentially, if we divide it into some number of rows, let me just call that Q1, then the total number of members in the band is multiple of this 5. And I'm using deliberately the quotient terminology, but it's some integer, and 3 is what's left over. We apply the same condition to the formation B. We're still talking about the same total number of members. Each row has 6 members, so it would be some multiple of 6 plus a remainder of 5. And then the question is, if we were to divide this into each row which has 7 members, then what's left over? So it's really just about finding the remainder when n is divided by 7 given these two conditions. So the easiest way would be to list out these numbers. You can see the least one is 3, and then you just keep adding 5. So 8, 13, 18, because we're just adding multiples of 5 to it. So 23, 28, 33, so on and so forth. We also know that the total number of members has to be less than 50. We'll do the same thing with the second case. So it would be 5, 11, 17, 23. So we kind of see, well, here's a common number, and 29. And since there has to be only one answer here, and that's why I think this constraint is here, we can just work with 23. So the least value of n that satisfies this condition is 23. Then we say, what's the remainder if we divide it into rows where there are 7 members in each? So 7 times 3 is 21. Remainder is 2. That's the answer B. Now, this question comes up in different forms on the GMAT about finding multiple values of n that satisfies this. And another way you can think about this is to try to make, meaning add something on this side, so this is a multiple of 5. So for example, if I added 2 to both sides, this is indeed a multiple of 5. But if you add 2 on that side, you'll see that's not a multiple of 6. So what you're trying to do is to make n plus something to be a multiple of 5 and then also a multiple of 6. So we go to the next value, which would be 7. So n plus 7 in that first case would become 5q1 plus 10, which is indeed a multiple of 5. But if we add 7 to that second condition, actually, let me go back to this one, then it would be 6q2 plus 12, which is also a multiple of 6. So the idea is to make this expression to be the same and make one a multiple of 5, other multiple of 6. That means n plus 7 must be a multiple of 30. 30 times, say, q3, which means n must have this form. And you can see if q3 was 1, that's going to give me the least value, which is 23. And if you need to find the second one, just make q3 2, which would be 60 minus 7 or 53, or simply add 30 to this. And because you'll notice in this question, they constrained it to be less than 50. That's why all of these higher values are not acceptable. And that's why 23 was the answer. So the reason I spent this extra time on this question is that this concept comes in different flavors on the GMAT, whether it's in data sufficiency. So make sure you've kind of dealt with it, thought through this, and are ready to have a method in the exam, because you don't really have much chance in the exam under time and pressure to be coming up with some new strategies. So to summarize, the answer is B.